All right, let's talk about the universe. I want you to imagine it's like one giant kitchen, and everything in it, I mean, everything, the water you're drinking, the air you're breathing, even the phone in your hand, it's all made from a kind of cosmic cookbook. Today, we're going to peek inside and figure out the basic recipes for pretty much all matter.
So let's start with a really simple question. Have you ever just stopped and wondered, what is all this stuff around us actually made of? At its core, it's all just stuff, right? But how do you organize it? Luckily for us, chemists have come up with a brilliant system for exactly that.
And here it is. This is our map. Now, I know, it might look a little complicated at first, but trust me, it's our guide for this whole journey. By the time we're done, you're going to see how it all fits together, starting right there at the top with matter. We're going to break this down into 5 simple parts. First, we'll tackle that first big split in our cosmic kitchen. Then, we'll meet the pure ingredients, the elements. After that, we'll see what happens when you follow a strict chemical recipe versus what happens when you just mix things together. And finally, a little bit of kitchen magic, how to unmix them.
Okay, let's get into it. That first big distinction. All the stuff in the entire universe can be sorted into 2 main buckets. It's either a pure substance or it's what chemists call an impure substance, which, we just call a mixture.
So what's the actual difference here? Well, a pure substance is, pure. It's made of only one kind of particle. Think pure sugar or a bar of pure gold. Simple, right? But an impure substance, a mixture, that's when you just physically toss different things together. Like making a trail mix by throwing some nuts and raisins into a bowl. There's no real recipe, you just mix them up. Let's stick with the pure stuff for a minute. We're going to start with the most basic building blocks you can find in our cosmic cookbook, the elements. These are the fundamental ingredients. You absolutely cannot break them down any further. And this is the key thing to remember. An element is a pure substance made of only one type of atom. We're talking about things like iron, oxygen, or gold. You can't just do some kitchen chemistry and break gold down into something simpler. It's just gold. That's as basic as it gets. Now, not all these ingredients are created equal. Elements themselves have their own categories. Take a look here. On one side, you've got your metals. These are usually shiny, dense, and fantastic conductors of heat and electricity. Think of a copper wire. On the other side, you have nonmetals, which are pretty much the opposite. They're often dull, not as dense, and really bad conductors, like a chunk of sulfur. Each one has its own personality that tells us how to use it in our recipes. So we've got our basic ingredients, the elements. But what happens when you combine them following a very, very specific recipe? That's when you make something brand new. That's a compound. This definition is so important. A compound is when elements are chemically combined and, this is huge, in a fixed proportion. This isn't just tossing stuff in a bowl. This is a real chemical reaction that has to follow a strict recipe. A perfect example is water, H2O. It's always 2 hydrogen atoms for every 1 oxygen atom, no exceptions. And what's so wild is that the end result is a totally new substance. The original elements, they lose their old identities completely. Think about it. Hydrogen and oxygen are both gases at room temperature. But when they chemically combine to make water, you get a liquid. You can't just filter them apart either. You need another chemical reaction to break those strong bonds. Okay, so we have covered pure substances. Let's hop over to the other side of our map, impure substances, or what we call mixtures. If making a compound is like baking a cake with a precise recipe, then making a mixture is like throwing together a salad. You just toss all the ingredients in a bowl, and this really spells out the differences perfectly. In a mixture, you can have any amount of each component, and, this is the most important part, they all keep their original properties. Salt mixed with water is still salty, and it's still watery. And because they're just hanging out together, you can separate them using physical methods. Let's use a classic example to really nail this down: iron and sulfur. Okay, so on one hand, you could just physically mix them. You'd have a pile of yellow sulfur powder with gray iron filings in it. Each one is still itself. Now, what if you heat that mixture up? You get a chemical reaction, and you form a brand new substance, the compound iron sulfide. It looks totally different, and as we're about to see, it behaves totally differently too. So how can we prove these 2 things are different? Well, it's all about their properties. If you take a magnet to that simple mixture, what happens? Whoosh! The iron filings jump right out. Why?
Because the iron is still just iron. It's still magnetic. But now, try that with the compound, the iron sulfide. Nothing. Absolutely nothing happens. That iron has chemically changed. It's lost its old magnetic personality because it's now part of a totally new thing. You know, that last example is the perfect lead-in to our final section. Since the parts of a mixture keep their own properties, we can actually use those properties to pull them apart again. Think of these as special kitchen techniques for unmixing our cosmic salads. We literally just saw the first technique in action, magnetic separation. It's about as straightforward as it gets. If one of your ingredients is magnetic, like our iron filings, and the other one isn't, like the sulfur, you can just use a magnet to yank it right out. And here's exactly what that looks like. As the magnet gets close, those magnetic bits literally leap up to meet it, leaving all the non-magnetic stuff behind. It's a fantastic example of using a unique physical property to sort things out.
Here's another super common one, filtration. This is what you'd use to separate a solid that won't dissolve from a liquid, like sand from water. The idea is so simple. You use a barrier with holes that are big enough for the liquid to get through, but way too small for the solid particles. And this is the classic lab setup for it. You pour the mixture through some filter paper. The liquid, which chemists call the filtrate, drips right down into the beaker below. And the solid stuff that gets stuck behind, that's called the residue. Honestly, it's the exact same idea as the filter you use for your coffee every morning. So there you have it. That's the basic map of all the stuff in the universe. We've got our simplest ingredients, the elements, the complex chemical recipes we call compounds, and the simple toss-ups we call mixtures. So the real question is, as you go about your day, what are you going to see differently now? Is that glass of salt water a mixture or a compound? What about the air you're breathing? The world is just full of these cosmic recipes, and now you know how to read them.